from last semester. So this was still working under the same theme of those urban heat island effects, but specifically Robi's group, so Robi's our representative from this group today, is going to talk about some potential behavioral impacts of those urban heat island effects. So I'll let you take it away, Robi.
I heard a yes in the background, so I'm glad there's behaviors here. All right, so as we've explained before, but I'll explain again, the urbanization of local areas causes the urban heat island effect, which is due to some structures that get hotter faster than more rural areas. So we've studied extensively the terrestrial effects that this has, but there's not a lot of aquatic environments that have been studied. And around here we have a lot of lotic aquatic environments, flowing. So we can study the change there very easily, so that's what we chose to do. We also chose to use ectotherms because they are very easy to affect with temperature since they don't regulate their own body temperature. And a very common ectotherm that's easy to observe in areas around here is the crayfish. We chose the reticulated crayfish, or Faxonious, Erichsonianus, honestly because we caught the most of them. And we decided to put them under temperature treatment and a control treatment to see how it affected their aggression behaviors. We chose aggression because it's been studied extensively. Crayfish are a very good example of aggression, and because it's easy to see. We can rate it easily. We can see obvious signs. We even had like a pre-made ethogram that we could use from other studies because they're so, I guess, representative of aggression. And so we hypothesized that as the temperature increased, the levels of aggression and the duration of the accounts of those levels would increase. Our null hypothesis then was if there's no effect, then there would be no change. So we went and got 40 male Faxonious Erichsonianus from the Tallahatchie Creek, which is the name of the creek that's right behind Cooter Brown's. And we got our control and UHI treatment temperatures from the USGS temperature site because we weren't actually able to have the time to measure temperature gauges ourselves. We went to the site and we found a similar creek to the Tallahatchie that was actually more urban, and that's where we got our urban temperatures of 24 to 25 degrees Celsius. And then we used a study that we had read before, Brands et al., and their research, and they said that it changed about 3 degrees. So we subtracted 3 degrees from that and got 21 to 22 degrees Celsius as our control. We then set up 2 38-liter aquia with air stones and gravel and some cut PVC pipe for housing. We put in temperature gauges, so we had a little thermometer on each one. They were completely isolated from each other when they were put in these tanks. And for the non-heated treatment, we didn't add any need for heat because it was room temperature. 21 to 22 degrees was about where it stayed all the time. We measured temperature daily. We checked for any dead daily, and we fed them 3 times a week. So we then placed them in and let them get acclimated for a week. And we actually added heating elements for the 24 to 25 degrees Celsius treatment. So both sets actually had 10 crayfish in each tank. They were actually paired before we took them out to fight them. We paired them by carapace and chelae size. They were all within the range of 1 to 3 centimeters in both. And they were marked by a whiteout pen to keep track of not only which fighter we had, we numbered them 1 through 10 and then 10 through 20, but also to make sure that they were correctly paired. Because if there's more than a 10% difference in size, we already know who the winner is. So we used a 6.8 liter plexiglass fighting arena. This is it, the example of it on figure 1. So 2 crayfish from each tank were taken and put in each section. The partitions actually kept them from being able to sense each other at all. And it was fresh water. We reused no water. We completely switched it out at the end so that they could not smell any other crayfish that could cause any other aggression behaviors. After a 15-minute waiting period in which they acclimate to the water, we remove the partitions that allow the 2 fighters to go against each other. And we observe for 15 minutes while recording. The reason we record is because a lot of these fight behaviors are actually extremely fast. Like the -2, the tail flip, they can retreat in seconds. So we might miss that, and we might miss how long it was, or when it happened and what was happening right before it. So we decided to record it. We record every trial, and then we prepped for the next trial by dumping all water, rinsing it, and then resetting everything. The only difference in the fight trials that we had for the heated element was the water was heated beforehand. And there was no real way, without changing the environment by adding light, that we could keep the water hot the whole time. So we measured before, during, and after the trial to make sure that any temperature change was negligible. And it was less than a 1 degree difference every time. So we then analyzed our data by reviewing the videos that we had, and we decided to do count and duration, which count is how many times that occurrence happened. So we tallied that in an Excel sheet. And then duration is the overall amount of time was spent at those levels. So we actually timed every single interaction that happened, and then we added all of that together for our final for each trial. And we used this ethogram here and created not only what we have here, the levels, but we created more levels for us to look at. We wanted a little more work. Retreat levels of -2 and -1, because those are actually non-aggressive. They're trying to avoid a fight. So that could skew data. So we decided to create a whole nother section to show that. And the non-escalated levels of 0, 1, 2, and 3, because they're not trying to fight here. They're trying to keep from a fight happening. They're just trying to back away. And then escalated levels of 4 and 5, where they are trying to kill each other. They're completely manipulating each other, trying to rip off limbs, and it gets really aggressive there. We used a multi-analysis of variance test for each count and duration, and we also used subsequent ANOVAs because we wanted to see exactly where any difference might occur, and everything was set to a significance level of 0.05. So our first MANOVA actually showed that count had no overall significant change, and our second MANOVA showed that duration had no overall significant change. But we did do the subsequent ANOVAs to see if there was any change in certain levels. As I said, the negatives might have actually thrown off our data a bit. So we did find that there was a significant change at levels 1, 3, and 5 in the count of how many times these interactions occurred. So that's 2 non-escalated levels and an escalated level. And you can see here, there is a significant change in our warmer temperature. So our results show that there was some change, but we can't accept our hypothesis or reject our null hypothesis because there was no overall change. But we can say that there is some behavioral change when it comes to aggression behaviors in crayfish because of temperature. And other studies have actually shown that there is a change in timing of mating and molting behaviors. So even these minor behavioral changes at these low temperature changes show that they will change how they interact in their environment, which will change the flow of ecological system. And if we change the flow of the ecological system, we disrupt the systems around us. And to minimize that, we need to do things such as add lighter concrete to our urbanized areas, add green spaces, and enforce more emission standards, because if we're changing the way the world works around us, we'll be making an impact that we don't want to make. Thank you.